Hello, excuse me. Hello, I'm Dr. Royce. I'm a forester, and this is what I manage. Looking at this picture, this is what I have to work with. My specialty is in operations research, or sometimes called systems analysis, or in the business school it's called management science. But in general, it's about making logical decisions based upon the data that you have. Operations research at NC State is part of the Department of Industrial and Systems Engineering. I'm also part of the Department of Forestry. Um, Also, sometimes I'm called a fire scientist because I do research in fire. Um, but this picture captures what forestry and forests are. A large, complex system from the large scale. This picture covers about 877,000 acres of forest land. And forestry goes from the large scale all the way down to the molecular scale. And you are studying the molecular scale with Dr. Lucia right now. So forestry is everything in this picture. Even the atmosphere is part of the forest. This is where, but this picture, this is where wood comes from. And if you were a forestry student, you would be trying to figure out how to manage this property in order to achieve the objectives of the landowner or the agency that owns the land. This is another broad scale slide. It's talking about North Carolina's market for timber. Basically, without markets, there would be no need for forestry. And people need wood. And markets are just a reporting of what the price is for wood in an area. So these graphs are average prices for stumpage, including saw timber and pulpwood in North Carolina. So these are quarterly reports. Each one of these points, actually, if you look at I guess you can't see my pointer, but each one of these points on the graphs, that's a quarter report. And so you can see how from 2015 going up to 2025, you can see how there's been a gradual increase in value of timber over time. It goes up and it goes down. The nice thing about forestry is you don't have to harvest it when it's down. You wait till it gets up, and you make more money just from waiting a little bit. The previous picture that we were just looking at was a snapshot in time of a forest. While this is an average summary of what people were getting paid for timber over this 10-year period. And you can see that the saw timber is for pine, which is the dark blue line, I think it is. It's about $27 per ton is what it's selling for. The green line is for hardwoods. And hardwoods and pine, they kind of go together. They're different. They have different products that you make out of these. Pine is mostly going into construction products and paper products and all different types of products. But hardwood is more specialized, going into furniture, cabinetry, doors, floors, barrel staves, things like that. The bottom graph is looking at pulpwood. Again, the blue is for pine, the green is for hardwoods. And you can see that the price of hardwoods is a lot lower. It's at it's about $7 per ton is what the people are getting paid. Again, stumpage means what the landowner is going to receive for selling his timber. That's stumpage. And usually when you're harvesting a stand, you harvest both saw timber and pulpwood in the same stand. So what I want to go through here today is the harvesting timber using the machines common in North Carolina. So basically there are 8 processing steps to get wood from the field to the mill. So you have the standing timber, and now you want to get it to the mill and drop it off for them. There's many different machine types that can be used, but there's still 8 steps that you definitely have to go through. In the following 4 slides, I want you to sum up the hourly cost of all of the machines. They should appear on the slide as you go through it. There are 2 types of filler bunchers, wheeled and tracked, and the difference really is that is the ground pressure that they apply. So wheels have higher ground pressure than tracked, which has lower ground pressure. Step 3, the skidder, it picks up the trees that are left on the ground by the filler buncher. It's a bunch of trees that get picked up and drags it to the roadside deck or landing or where the loader is. So you have a place where you have to take the trees to. Step 4 and 5, processing. That's delimbing each tree and cutting them up into desired lengths, usually based upon length and diameter. Step 6 is the loader. So you get the logs at the processed logs at the deck, and you load it onto a truck. So the loader is a very important position. The processor and loader often are the same machine, but the processor and the loader can be different machines also for different efficiency purposes. Step 7 is trucking. So you're carrying approximately 30 tons per load of tons of wood to the mill. And step 8 is unloading the truck at the mill. Now on this recording of my talk, there's several videos that come up, but the videos don't show up on the recording of this video. However, if you go and look at just this straightforward PowerPoint presentation, you can see the videos of the trucks if you want to look at it. Okay. Anyway, the slides coming up, they go over the steps 1 through 8. You don't have to click on the button to play because it doesn't work on this video, but it will work when you're looking at the PowerPoint presentation. So for each machine, I want you to add up the dollars per hour for that particular machine, and that's the hourly operating cost. And that takes into account lots of different variables to come up with the dollars per hour to run a particular machine, including ownership, buying, insurance, fuel, paying for the operator, overhead, benefits, just everything that goes into owning and operating a piece of machinery. You don't have to know that for this problem, but forestry students definitely have to learn how to cost up machine systems. Assuming that there is only one filler buncher, one skidder, and one loader in this system. So we're just keeping it simple. We just have one of each type of machine, and you have the price of each type of machine. Okay, so this is a feller buncher. And this is all you can see on this video, but if you go to the video, you can see it in action. So it has this big head in front. That's the tool that cuts the trees, and it grabs the trees. You can see those little arm-like things. It's kind of based upon the a person's hand and the way it was actually first designed, so that they can grab one tree and then grab another tree and then grab another tree. And eventually your hand is filled up, and so you have to set it down into a bunch. So this is a feller buncher. It's a tracked feller buncher. This is a John Deere. It has a deer on the front of it, and that's John Deere's color. They always go with green and the yellow head. So I encourage you to go to the presentation, the PowerPoint presentation, so you can see what it's looking like. And let's see, I think I had $148 per hour to own and operate this piece of machinery. Okay, so now it's okay. Now we're at the skidder. That's the second process. The feller buncher, it cuts the trees down and bunches them up into a pile. The skidder picks up those piles and drags it to the deck. And there's a loader behind it, and the loader is processing the logs on this particular job. But this is a Tiger Cat skidder. So John Deere and Tiger Cat are not the only, but two of the major forest machinery companies on Earth. So the video is not working on this one. It's too bad. It's a good video. This is the loader. This actually has a loader and a processor. So the loader processor combined, I'm putting down as it's costing $150 per hour to own and operate this loader here. And out in the field, you can see there's another machine, and that's a processor. So that machine's picking it up, cutting them into lengths, delimbing them, and then it takes them all the way over to this pile here, and it stacks them in the pile for the roadside. Again, this is a good video, but it's not very good without being able to look at it. Okay, and the last operation is unloading log trucks at a mill. And here, I mean, it's a very interesting situation, but over my head, there's still pictures of a crane coming down and grabbing a truck full of logs, which is just going to unload the truck all in one sweep and then pile the logs over to the left-hand side. On the left-hand side, we have a picture of a truck coming in, and the grapple is grabbing it, and it picks it up and carries it away to put in the pile for the mill to be used. If you notice, it's kind of sped up a little bit, but to unload a truck, it just takes one grapple full. It picks up that 30 tons and puts it into the pile for to go into the mill. And at that point, it's free on board. So they get paid, no matter what happens once that grapple picks it up. The trucker gets paid. But the trucker doesn't get. The trucker and the logger gets paid, I should say. Okay. So now we're back to Timber Mart South. We're looking at markets. FOB. FOB stands for free on board, which is a term that goes back to the days of sailing, where free on board means once you load your product onto the ship or load your product into the mill, the logger is no longer responsible for it. All the responsibility goes back to the mill. So that's what that basically means. So here we have stumpage prices again. The top 3 rows of prices are delivered timber, and again this is for North Carolina, and this was for, I think it was for the 3rd quarter last year. So anyway, excuse me. So you can see that saw timber delivered price is $47.21, and if you go down below that, you have the stumpage price. So that's what the landowner gets paid. So the landowner gets paid $29.95, and so there's about it's a little over a $17 difference between what the landowner gets paid and what's the logging company gets paid. So they get paid 27 minus 29, or basically 30. So it's around $17 more than what it costs for the than what the landowner gets paid. So where does that extra money? What's happening here? Well, it's kind of like profit. So if all of their logging costs were just exactly what they were getting for it, then it could be a pure profit thing. Or it can be, what's more likely is some of the owners will be on the job and they'll get paid part of the profit. And each of the some of the employees might be hourly, and so they are included in that cost. So they're included in the 27.21, but the owner operator gets most of the difference. So it's not all profit. Just it depends upon people are getting paid and how overhead is being handled. Okay, and so going down the list, we have oak prices. Oak obviously is more valuable than pine. Then you have mixed hardwoods, which is kind of a mixture of really good hardwoods. Might have some oaks in it, but it's not. It's just a little bit more than pine. Then you have pine chip and saw. Chip and saw is just as it sounds like. You can chip the outer parts of the log, and on the inner parts of the log you can saw into saw timber. That's chip and saw. Pine ply logs. Ply logs are just logs that are cleaner on the outside. You don't see very many knots or anything indicating a knot. And so it's a more valuable log for making plywood. Then you have pine poles. Poles, look at that, $68.11. Poles are the most valuable forest product there is. But the reason it's so valuable is there's not as many poles out there on a stand of trees as there is saw timber. Poles are pretty stringent characteristics that it has to have in order to be qualified as a pole. And then you have pulpwood. So pine pulpwood, it's $29.39. Delivered price. Pine pulpwood stumpage is $10.15. So it's a little bit more than $19. So actually the logger in this situation is getting paid more for. Somebody might think they're getting paid more, but they're getting paid more for delivering less pulpwood. So that's an interesting situation. Basically, it means that the owner, if they're buying pulpwood, they're going to pay. Generally they have to pay a good going price for all the logging associated with it. So delivering the logs is expensive for pulpwood because it's smaller wood. But the differential makes it so that the owner operator can actually make a profit with pulpwood also. Okay, so the question that I wanted to give to you is, given the total dollars per hour for the machine systems, okay, that's summing up the 3 different machine types that I had on there. So I had the filler buncher was $148 per hour. The skidder was $145 per hour, and the loader was $150 per hour. So you add that up. Plus you have an estimate for trucking costs of it's 8 cents per mile per ton. So the trucker gets paid 8.6 cents per mile per ton. So you have to remember it's a 30-ton payload, and you're going, in this example, you're going 75 miles. So that's what the logger is getting paid. So 75 miles times 8.6 cents per mile, and that's how much he'd be getting paid per ton. Also, given the above data from Timber Mart South, again, this is the market report that comes out every quarter for not just North Carolina, but from Virginia all the way into Texas and parts of Oklahoma. It doesn't go to Oklahoma, but it goes to Arkansas and Tennessee. Excuse me. Okay, so I want you to figure out how many tons per hour does the machine system with 1 filler buncher, 1 skidder, and 1 loader need to break even. So how many tons per hour they need to break even. You have to just figure that out. It's not very it's not difficult arithmetic, but you just have to think it out a little bit about how they can make money out of this. how much they have to produce to break even. In reality, the owner operator would go through a machine line balancing process where you try to figure out what combinations of machines together would optimize their production cost. Would minimize their production cost. You don't want to optimize production cost. You want to minimize it. And trucking, by the way, is normally just a contracted process. Most logging companies don't own the trucking companies. Some do, but most of them don't. And that puts a lot of the workload into the trucking company, who has to truck the logs for a distance. Okay, so that's my question, and hopefully you can answer this question. I wanted to go through, because when in logging, there's so many variables that can change your profitability. So there's production factors, and the basic ones are the loads delivered per day. Obviously, the more loads you can deliver per day, the more you're producing. The days worked per year, obviously the number of days that you're working, you're going to get more loads delivered. And the tons per load, which I already said was about 30 tons per load, but sometimes, because of the arrangement of the logs or shape of the logs, you'd be less than 30 tons per load. 30 tons per load is the limit. So if a state patrol stops you and wants to weigh your truck, and it's over 30 tons, you get fined. So anyway, all that, the loads delivered per day, days worked per year, tons per load equals the number of tons per year that you're going to produce. Now let's go through some of the costs that are associated with it. So the scale of operation. Hopefully this shows up okay. Yep. So my little line came up here. This is looking at the graph of harvest unit size in acres versus logging cost in dollars per unit. So what it's saying is, as you have more and more acres to harvest, the less expensive it is for you to do the harvesting. And what that's showing is that there's a move-in cost. So moving your big machineries from one place to another, it costs money. It can cost close to $1,000 per machine that you're moving. So you have these machine moving costs. If it's just an acre, or less than an acre, it's almost infinite because you never make any product out of it. But if you go out to, say, 40 or 100 acres, it really gets cheaper and cheaper. Eventually it levels off, but harvest unit size varies. And a lot of the harvests that you see nowadays, because of a bunch of different reasons, a lot of the harvest units are less than 20 acres or less. 20 acres isn't very much for a logger to work with. 40 is pretty good, and if you got up to 100, it's much better. It's leveled off as far as harvesting, logging cost is concerned. Okay, tree size. Let's see if this. Oh, okay, that came in. So log size. Again, this is pulpwood would be down on the lower left of this graph, whereas a big old growth log would be way on the right of this process. And all that's saying, it's costing you more money to drive up to a tree and cut it. So if you have to do a small trees, it might be like you have to cut 100 trees to make enough money to break even. Whereas if you're doing an old growth stand with giant trees, it might, I shouldn't say giant trees. Sometimes the trees get too big for modern equipment. But let's say it goes up to 30 inches in diameter. Harvesting one tree is almost the same effort as it is to harvesting 1,000 trees, those small trees. But it's much less time. It's just, much quicker. So the log size is a big thing. Let's see what else I can do. Extraction distance. Oh, this is a good one. Okay. So extraction distance, we often refer to it as average skidding distance. And average skidding distance is what it's saying exactly. It's how far do you have to drag the wood on average. So if it's like the optimal skidding distance has been figured out mathematically to be it varies with cost and machinery type, but it's someplace around 700 feet. That's not very much. That's like, that's 7 football fields, right? So that's a long distance. So no, that's not 7. That's only 2.5 football fields. So anyway, if the further you have to skid the trees, the more expensive it is. And that's just a cost, obviously. A lot of one way of looking at it, if you built roads to every tree instead of skidding, that would be monumental costs. But if you build roads so that your block that you're harvesting is around 700 feet, then your optimal is in terms of your skidding distance. So that part is a real trade-off. Okay, what's this one? Okay, thinning versus clear cutting. So obviously with pine we do a lot of thinning. So you just see thinning going on all over the state, and all that means is that you cut out some of the trees and leave behind other trees. You get two things out of thinning. You get to free up a lot of the competition between trees, so that the bigger trees will grow faster and bigger. Whereas thinning also gets you a intermediate source of income. So thinning is usually around 20 years old. So you go and thin, and then you let your trees grow for another 10, 20 years, and they can grow faster. So, but at 20 years, you've got a thinning income. So it gives you um, a good balance um, to have thinnings in your forest. Most loblolly pine plantations go into a thinning regime. Okay, so this is a special constraint. So special constraints, this is a killer. Um, means that you have special things that you have to do for this stand. It's not just every piece of land is the same. Every piece of land is different. Every ownership is different, and so they have different desires. So say for one very straightforward one, if you have a stream going through the middle of your um, property that you want to harvest, you might have to build a road over that stream. Oh, that's going to cost you. You have to build a bridge over the stream. That's going to cost you some. So building a bridge. Another one might be you don't want to have compaction. So you want to use uh, tracked vehicles, or you want to have double-tired vehicles just so that they have less ground pressure. Or you might want to put mats down on the grounds for the trucks to go on so that they're not driving on the soil, they're driving on mats, which spreads out the compaction a great deal. So there's all these little special constraints that landowners can put onto you, and they cost money, basically. So I think that's the end of it. Hopefully you have learned something, and hopefully you can figure out what the minimum, the break-even production for your system is. And that's it. Have a good day.